Hi ho, Kermit the Frog here. It's the Learning Show! It's time to play the music. It's time to light the lights. It's time to meet the math bit on another day of class. It's time to open Chromebooks. It's time to get it right. It's time to get things started.
Why don't we get things started?
It's time to get things started on the most sensational, inspirational, celebrational, math sensational. This is what we call the Learning Show. Happy Friday, everybody. I bet you thought for a moment that I actually got turned into a frog. But never fear, that did not happen. I'm here, and so we're glad you're here. And you know, I've never seen a frog play the piano before. Now, I've seen a cow play the piano, and she was quite a musician. But I thought, you know, if a frog's going to play the piano, he's probably just going to croak. But we're glad Kermit was able to help out this morning. And some of you, you need to be getting me your assignments. I don't know why you're not giving me your assignments. What'd you say? Kermit the Frog told you not to turn in your homework? I can't believe that. What'd he tell you? He said, rip it, rip it, rip it. No, he did not say rip your homework. He's a frog. He said ribbit, ribbit, ribbit. And so get the homework turned in, tape it back together. You know, I need your work, and so I also need your attendance. So make sure, you can pause this video right now, but make sure you fill out the attendance form. It's Friday, May 8th, and make sure you filled it out for the whole week. And so we won't be counting you absent, so get that in. And remember that Sunday is Mother's Day. You can't have any excuse. Oh, we've been home, I forgot. And so make sure you have a special plan to do something special for Mom on Sunday. And so you think about that too. You still got a day or so, and get the attendance taken and we'll be ready to start. We've been doing inequalities all week. We did the ands and ors, the compound inequalities, then we did the absolute values, land and gores, and we're going to kind of keep on that theme today, and we are going to have a worksheet, and so that's all linked to the notes today. And we're going to talk about polynomial inequalities, and you're going to have to FOIL, and they're going to have quadratics and cubics and things on that. And so we're going to get started with that. And so here we are. And this is notes number 123. So make sure you write down 1, 2, 3. Do, re, mi, A, B, C. 1, 2, 3. Do, 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 do. And so we're going to talk about what values of x does x squared minus 3x minus 10 would give you an answer that's negative, that's less than or equal to 0. And we could sit here and go, oh, maybe 0? Yeah, 0 works. 0 squared minus 3 times 0 minus 10 is less than or equal to 0. 0 works. Color it in. You know, guess and check, even though some of you think that's just wonderful, is not the way to go. You need a thought process. We need to think. We don't just want to say, oh, let's guess 10. Oh, yeah, I think 10 works. 1. Yeah, 1 works. 1 minus 3 minus 10, that'd give me negative 12. Yeah, that'd work. So let me mark in 0. Let me mark in 1. Let me just guess around. 2? 4? Yeah, 2 would work. Yeah. This is not the way to go. We need a thought process. We need to think through what values of x that there's infinitely many numbers to plug in. We could be here a very long time. And so we want to think through how we could solve an inequality that has a quadratic in it and not just guess around. Guess and check is not the way to go. And so we're going to kind of jog your memory here a little bit on certain values. If A times B equals 0, then what did we used to know to be true? Jack? Yeah. If A times B equals 0, then we knew that A was 0 or B was 0. That's true. It's a true statement. Well, what if I said this? If A times B is less than 0, if we're multiplying two numbers together and it equals a negative, what has to be true about those numbers? Jordan? Yeah, one of them would have to be negative, like A is less than 0, and at the same time, B is greater than 0. One is negative and the other one's positive. That's how you get a negative. Or, what else could be true? Lauren? Yeah, the A could be the positive one, and the B could be the negative one. Either one of those is true. Either A is negative and B is positive, or A is positive and B is negative. What if I multiplied two numbers together and the answer was greater than 0? If the answer was positive, then what's true? Jacob? They're both positive. Yeah, A is greater than 0 and at the same time. See, these ands and ors are important. B is greater than 0. Or, what's that, Rosie? Yes, they both could be negative. And so A could be less than 0. And B is less than 0. Well, that is a lot to think about. Not too tough, but easily thought about. Now let's go up here to this problem that we just did. If we factor this, what would x squared minus 3x minus 10 factor into? Ethan? Yes, it'd factor into x minus 5 times the quantity of x plus 2 is less than or equal to 0. Well, see, this is two different factors. It'd be like, here's my A and here's my B. And I want to know when they're less than or equal to 0. I want to know when they multiply to give me a negative. And so, if I did it this way, down here I would write, well, x minus 5 could be negative. And at the same time, this is a lot of writing, x plus 2 could be positive. Well, when does that occur? Let's solve these. Add 5 to each side. That's when x is less than or equal to 5. And at the same time, x is greater than or equal to negative 2. But that, one could be negative and one could be positive. But there could also be another situation where the x minus 5, or, see, here's our other situation. X minus 5 could be positive, greater than or equal to 0, non-negative. And at the same time, the x plus 2 could be less than or equal to 0. Nah, I wrote the wrong thing. Thinking ahead and still writing behind. And so the x plus 2 could be non-positive, less than or equal to 0. Well, that occurs when x is greater than or equal to 5. And at the same time, x is less than or equal to negative 2. Well, only one of these works. Can you be greater than 5 and less than negative 2 at the same time, Joe? No, this does not work. It's not an and, it'd be an or. If you're greater than 5 and less than negative 2, you're a gore, an or. But see, this is the one. You can be less than or equal to 5 and at the same time be greater than or equal to. Imagine doing the problems all like that, writing them all out. Oh, that'd be terrible. And so, what do you think the fast way is? 5. X plus 2, what's the solution? -2. And then just like Wednesday, less than and graphs land. So all you do is plot those 2 points and then go less than and makes land, make land in the middle. You mean I don't have to write all this out? No, just make people think you do. Just make people think that you can think all through all that. It's like, I don't want to think through all that. Look at this next one. What would x squared minus 2x minus 8, for what values of x would it be greater than 0? You know, and I'm just going to guess around. No, we're not guessing around. And so what would this factor into? Madison? Yes, 4 and 2. But then which one would have the negative sign? Yes, the 4 would. Good job, Madison. X minus 4 and x plus 2. So we're going to write this out, but I promise this is going to be the last time we're going to write this out and think about what's really going on. And so I have 2 things. I'm multiplying 2 factors, x minus 4, which would be like my a right here. And then this would be like my b right here. And we're multiplying 2 things together to equal a positive. Well, if you're multiplying 2 things together to equal a positive, that means x minus 4 has to be greater than 0. And at the same time, I forgot to write the 0. And x plus 2 has to be greater than 0. And at the same time, x is greater than -2. Now, that's a little different. Is this true? Can you be greater than 4 and greater than -2? Yes, but you have to be greater than 4. All numbers greater than 4 are also greater than -2, so it's not like the last one where we pick which side is true. This side just becomes x is greater than 4. But there is that other scenario. Remember, they're either both positive or they're both negative. A is less than 0 and b is less than 0. And so that would mean that x minus 4 would be less than 0. And at the same time, x plus 2 would be less than 0. And when we solve that, add 4 to each side, x would be less than 4. And here, if we subtract 2, x is less than -2. But if this is an and, can you be less than 4 and less than -2 at the same time? Ilya? Yeah, if you're less than -2, all numbers less than -2 are less than 4. And so that's what we want. And so that's our answer. X is greater than 4 or greater than 4 and or less than -2. And that's my answer. Is there a faster way? Mason? Yes, there is. What? If I was just going to solve this, x minus 4 would just give you a 4. And x plus 2 would just give you a -2. That's like when it's equal to 0. So those are my closed dots or open dots. And then I just look right here like we did on Wednesday. Greater or gore. How easy is that? You just find the points. And then you go and land or gore. We got this. You mean I don't have to write all that stuff out? No, just let your friends and neighbors think that you think all that. Just find the points and go and or, land and gore, and we got it. Okay? And so that is how we're going to do the first part of the homework. And so when you go to the first part of the homework, we're not done with the notes yet. When you go to the first part of the homework, you just factor this. We got x squared minus 6 is less than 0. What does that factor into, Cam? 3 and 2. Which one will have the negative sign? Yes, the 3 would, because there's a negative sign on the -1. -3 plus +2 is -1. But what are those points then? Abby? Yes, if this is 0, we want a 3 and we want a -2. And so this would be a 3 and this would be a -2. Are these closed dots or are these open dots? Elizabeth? Yes, they're open dots. Make sure you got your warm-ups done this week, because that's where we're testing you on the review of the closed dots, open dots. Now, how do we know if we go this way or this way? What would that be? Cody? Yes, this is less than 0. Less than and land. Now, how quick was that? Makes us all look like geniuses, I tell you. And so less than and land, greater or gore. This one right here, greater or gore. This one right here, oh, it's not equal to 0. So you got to not equal to 0. You have to subtract 3 from each side first. This one, distribute. And then subtract the 5. So it's set equal to 0 or set greater than or equal to 0. And that's a greater or gore. And so you've finished those. But we're not done with the notes because we have a back side to the worksheet. And you're such an expert on this, we got to add a little more. Okay? And so let's go back and let's look at the bottom examples when we get to higher order polynomials. What's going to happen when we get to higher values, like an x cubed or something? And so what you could just think about it, which would be a disaster. If I factored, we're going to do the last example on the notes, and then we'll show you how you could have done the first examples with a different technique. But if we had x cubed minus 9x is greater than or equal to 0, what values of x could I plug into that expression so the answer would be 0 or positive? Well, I'll plug in 9 billion. Okay, yeah, it'll work. Plug in 400 trillion. Yeah, they'll work. But where are the key points and where are the dividing lines for the things that work and the things that don't work? And so a key thing we're going to do is, Erica, yes, we're going to factor it. And we want to see the factoring on your homework. Yes. And so we're going to factor this. So first thing we're going to do to factor that, Cole, is pull out an x. And so if we pull out an x, we're going to get x times the quantity x squared minus 9x. Or minus 9. Sorry, the x went out. Oh, Mr. Nyson misspoke again. It always happens. Just listen to what I mean. And so then we factor this. Elijah, what's x squared minus 9 going to factor into? Yes, x plus 3 times x minus 3. Now, we're multiplying 3 things together to equal positive. Do you really want to think about, well, they all could be positive. Yeah. Or these two could be negative and this one's positive. Or these two could be negative and this one's positive. Or these two could be negative and this one's positive. And then we can write all that out and think about all the different combinations. And then which one would be the solution set? Oh, it's Friday, Mr. Nyson. It's Friday. What are you thinking about? And so, but we came up with this way just to think about each factor when it's positive and negative. And so what you do is you write each of these factors down next to a number line. X plus 3, x, and x minus 3. It doesn't matter which one's on which number line. But see, we already know on our answer we got 3 key points. And are they going to be open dots or closed dots? Lauren? Yes, closed dots, because it's greater than or equal to 0. So we have a closed dot at 0. We have a closed dot at negative 3, because that's when x plus 3 is equal to 0. And we have a closed dot at 3. So instead of thinking about it, just find these key points. Well, what do you think? If you were multiplying 3 numbers together and they were all positive, if I was multiplying all 3 of these together, and they're all positive, you'd get a positive. Well, that would be this far section. This section would be positive. Now, why am I coloring it? Because I want to color the positives. Then if you changed one of the signs, it would make it a negative, and that would be this next section. I don't want to color that. Then if you changed another sign, you'd be back to a positive. And then if all 3 were negative, that would mean it's a negative. Now, well, you didn't need this. Why'd you explain it that way? Because I'm not with you, so I'm trying to explain it the most efficient way. But here's really what you do. You graph each of these separate. This x graph would be right here at 0. And I want to know when it's positive. Well, it's positive over here. I could graph it, or I could just label it's positive over here. Positive, 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 positive. And over here it was negative, 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 negative. And I didn't graph it because I didn't want the negatives. Here, if I graphed x plus 3 is greater than 0, that key point is at negative 3. And if I want the positives, I would graph this way. But why? Why am I coloring that side? Because that would be the positives. Positive, 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 to ever. And here, Buzz Lightyear, this would be to negative, 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 infinity and beyond. And then if I graph this one, x minus 3 is greater than or equal to 0, well, the key point would be 3. And the positives would be over here. And the negatives would be over here. But the key thing is these solutions created regions in my graph. And one region is right here. I have positive times a positive times a positive. Well, that gives me a positive. This region right here, I meant to change colors. Why didn't we change colors? This region right here was a positive times a negative. What would that be? Jack? Yeah, that'd be a negative. Now, if we wanted the negatives, we'd color that. But see, we didn't because the original problem said we wanted the positives. This section right here is a negative times a positive times a negative. Well, what does that give me? Well, that gives me a positive, and we wanted to color that. And this section right here, if we were multiplying 3 negatives together, it would equal a negative. Now, we can't do greater or, gore, and less than and land because we got too many pieces. That only works when you got 2 dots. Less than and, land. Greater or, gore. But if you have greater and you got sections, you got to think about what's really going on, and the super duper shortcut doesn't work. So if we look at this problem, which we could have easily factored and set equal to 0, we get x squared minus x and subtract 12, and that's greater than or equal to 0. What would that, Dominic, factor into? Yes, x minus 4 and x plus 3. I don't really need a sign graph. My key points are what, Judah? You getting those warm-ups done? You know, on Khan Academy. You have to do those. And so the key points, Judah, are what? 4 and negative 3. These are closed dots. 4 and negative 3. Now, we said before, greater or gore. And you're like, we didn't need all this stuff. Yeah, just like I didn't think I needed YouTube and iMovie and everything else when we're sitting in class. I didn't need any of that. Now, guess what? Who would have thought all this would happen? Now I need to figure out all these skills. You know, sometimes my QuickTime doesn't record the whole movie. And so I'm talking for 10 minutes and only records the first 4, and then I got to say all this again. And those are things you never know. And it frustrates me sometimes. So I can just hope it's recording me right now. And not that I have to record the same thing I'm saying. But that's the answer. But what's really going on? Maybe sometimes I need this skill. See, x minus 4, when is that equal to 0? Well, that's equal to 0 of 4. And here we graph the positives over here. And that's why we graph that. But we're going to graph it in combination with this. It's negative over here. When is x plus 3 equal to 0? Well, it's equal to 0 at negative 3. And over here, it's positive. And individually, and over here, it'd be negative. We want to know the combinations. Well, there's sections here. Notice how a negative times a negative is a positive, and a positive times a positive, there's little plus signs here, is a positive. Yet a negative times a positive would be a negative. And that's why less than negative, less than and graphs land. And that's why greater or graphs gore, because the positives are on the end and the negatives are here. Okay? And so that's how we do that. So when you get to the back side of your homework, I give you two that you wouldn't need a sign graph for. Okay? But this one, make the x squared over here and make it positive. X squared minus 8x plus 16. Okay? Is greater than or equal to 0. This one, divide by 2 first. Divide by 2, divide by 2, divide by 2 before you start graphing it. And yes, if you get the same one twice, you write it twice. Same thing here. And your answer might be kind of interesting. This one is already factored for you. So your key points are 1/2, -1, and -7. And write those down on the blanks. 16, you're like, you didn't give us any. Why do you always do this to us? This doesn't look like the other ones. But factors can be multiplied or divided. To divide is to multiply. And so if we were doing this one, you would factor the top. And what would that factor into? Abigail? Yes, x plus 3 and x minus 1. And so the bottom would be x minus 5. And same thing, you write x plus 3, you write x, that's going to be at -3 is your key point. And you can line it up with the number line below. X minus 1 will be at 1. X minus 5 will be at 5. But the trick here is, are these closed dots or open dots? Well, what, Jack? Ooh, yeah. See, everyone thinks they're going to be closed dots. You think you're going to have a closed dot wherever -3 is. And here's 1, and here's 5. 1, 2, 3, 4, 5. And you think, oh, everything's going to be a closed dot. But the ones on top will be closed dots. Why won't the one on the bottom, Jack, be a closed dot? Oh, yeah, it's a restriction. X cannot equal 5, so that has to be an open dot. And so make sure you have an open dot at 5 when you graph your answer. And we want less than, so we want the negatives. We want to keep track of, we want to color the negatives down here. Okay? And so we're going to move me up here, and then we're going to look at the last two. And the last two, you just got to factor. Okay? And so maybe I'll move over here for this one. And so we'll just factor these and get these started. So what do we want to do, Bree? Yes, we want to set equal to 0. So we got x to the 4th minus, put that 10x squared in the middle. And then plus 9. Ryan, what does this factor into? Yes, it's going to factor into x squared minus 9 and then x squared minus 1. And then that's less than or equal to 0. Are we done factoring it? No. Riding down the highway in my makeshift Model TA. Ooh, yeah, ooh. It's a beautiful morning and it's gonna be a beautiful day. We're gonna keep on factoring through the problem. We're gonna keep on doing it right. I remember Mr. Nyson making me watch those Brady Bunch episodes. And it seemed like the song never ended. So x squared minus 9, what does that factor into? Asa? Yes, x minus 3 times x plus 3. Good job. What's x squared minus 1 going to factor into? X plus 1 times x minus 1. And those are the things I'm going to write down here. And these are all going to be closed dots. This one written kind of different because I didn't expand it all to get an x to the 4th. But this is going to be x minus 3 times x minus 3. You write it twice. Then we're going to factor the second part. And the first thing we're going to do is what, Judah? We're going to pull a 4 out. And if you pull a 4 out, you get x squared minus 4. Judah, did I tell you, are you getting your warm-ups done? Make sure we get them done. And so we're going to divide by 4. We're just going to forego the 4, because if you divide by 4, it's gone. And so really we just have the x squared minus 4. And what is that going to factor into? Hannah? Yeah, x plus 2 times x minus 2. And those are my 4 factors. You're going to have closed dots or open dots? Elizabeth? Yeah, they're going to be open because it's greater than 0. And so open dot 3, well, this is minus, so you're going to have an open dot at 3, another open dot at 3, an open dot at -2, and open dot at 2. Why do we write it twice? Because you're going to have double signs. You at 3, you're going to have negatives up to 3, and then you'll have negatives up to 3 again, and a negative times a negative is a positive. And so we need to write that factor twice, and then multiply the signs together. If you have any questions, let me know. It's hard to believe there's only 2 more Fridays left in this school year. And, you know, as Kermit says, time's fun when you're having flies. And it seems like even this, trying to do these lessons for you is going quick. So, hey, we miss all you guys. Send in your work. And if I ask you to send something in again, please don't be mad. Just trying to stay organized. And I hope all of you have a great day. We miss you all. And keep up the great work. Okay? Bye-bye.